Okay, I just want to provide you with a solution to the example problem you did in class to prepare for your test. And so the problem read, a 10-foot ladder is placed against a vertical wall, as we have pictured here. And suppose the bottom of the ladder slides away from the wall at a constant rate of 3 feet per second. So I've labeled the bottom of the ladder down here, or the base here, the ground, is X. And then the wall is vertical height Y. So if I'm sliding the ladder away from the wall, it'll be going this direction, and that's a rate of change. So that's dx dt, and that's equal to, it's given to me in the problem, 3 feet per second. So suppose it is sliding away at a rate of 3 feet per second. Then we want to know how fast is the ladder sliding down. So that's going to be down like this, which would be a dy dt. That's what we want to find out. So we need to find dy dt at the instant, and they give me this here, that the bottom is 6 feet from the wall. So how fast is the top of the ladder sliding down the wall when the bottom is 6 feet from the wall? So that's when the x distance from the wall is 6 feet. So that's x equals 6 feet. This is what I need to find out. And for each of the problems that you do, you need to have your diagram, because we'll be looking for that. You need to make sure that you put down what's given, because we'll be looking for that. And then you also want to put down what you're looking for before you get started. So I'm going to copy this diagram because I use it on the next page. So let me copy that, and then I'm going to paste it over here just so we can look at it. Okay. All right, so we need a relationship between the variables, and what we see is we have a right triangle, so we see that x squared plus y squared equals the hypotenuse, which is 10, and if that's squared, that's 100. So there's my equation that relates the variables. Once I have that, x squared plus y squared equals 100, I'm ready to now take the derivative, remembering that x is a function of t and y is a function of t. So x and y are both dependent variables. Therefore, when I take their derivatives, I need to make sure that I get primes with them. So that will be 2x dx dt. If you prefer, you can write that as x prime. That's not any different. Plus 2y dy dt. Again, that's the same thing as y prime. And that equals to 0. So remember that in this problem we're looking for dy dt. So we need to solve for dy dt. If we do that, we push the other term to the other side and divide by 2y, and we will get that dy dt is equal to minus x dx dt divided by y. So I'm going to need to know what y is, and then I could solve, because I know x is 6 feet. I know dx dt was given to me. I believe that was equal to 3 feet per second. So I'll get y from the Pythagorean theorem. X squared plus y squared equals 100. So that means that when x is equal to 6, then I have that y squared is equal to 100 minus 36, or 64. So y is equal to 8 feet. So I'm ready to solve now, because I know dy dt is equal to minus x dx dt, all divided by y. I know what everything is on the right, so that's equal to minus 6, and that's feet, times 3 feet per second divided by 8 feet. feet and feet will cancel, so I know that my units will be feet per second. That's good because that's what I expected. And so what can I cancel here? I got a common 2 in there, so that makes 4. A common 2 in there, that makes 3. So it looks like y prime or dy dt will be equal to 9/4, don't forget the minus sign, feet per second. And so when I write my solution, I want to make sure that I have the right sign, because that means that the ladder is falling down the wall, and I want to make sure that I have the correct units for the problem as well to get full credit.